Hi guys, welcome to our third part of modeling in RFEM 5. Today we are going over the graphical input of model data, and in this video we will create this continuous beam. Before we begin with that, I just want to show you guys how you can adjust the grid in RFEM at first, because sometimes if you model different type of structures with different sizes, it's very helpful for that. So the grid is dividing our graphical user interface into regular sections, and we are able to activate or deactivate the grid down here. Then next to the grid there is the snap option. If we activate the snap, we can snap automatically certain points, like to insert a new node. If we go up here and then say new node, you can see we can snap these grid points, but if the snap isn't activated, it's not that easy to snap a certain point. And this is also going to be very helpful for us in this clip when we are entering the lengths for the beam element later in the graphical area. Back to the grid, with the right click we can choose edit, and then we can open the grid and snap settings. As you can see, we can activate or deactivate the grid or a snap in this dialog as well. Then of course we can choose the type of grid that we want, like Cartesian or polar. Next, there's the option where you can set the number of grid points in each direction. And then we can activate up here the option dynamically according to size of model. And this will allow us that our grid is getting adjusted automatically to the size of the model. Down here we can set the space or the distance between those grid points, but we can keep that as 1 meter for our example. Then grid line spacing, we can keep that at 10 as well. And we can click OK. So now to get started with modeling our beam, for the direct input of data here in the graphical area, we can do that either up here on the insert, and then we can find here graphically, or using this toolbar down here where you can find almost everything that you need. During this video we will use this toolbar as it's quicker to access those commands. So unlike the previous two examples where we did create in advance to the member, nodes and lines, we are going to create the member directly in this example. For that we go up here and then we can find new single member. We already know this dialog from our last video. Again, all we need to do is to define a cross section and a material, what we can do down here on the cross section. And we click at this button here called import from cross section library. Then we can set the cross section as we've already done in the last video. Down here we will enter our material properties and then we can click OK. Then we can have a look under cross section if everything has been taken over as we'd like to, and then we can click OK once again. So now we can select certain points with a click in the graphical area and define the start and end points of our beam. And since we have activated the snap option, it's very easy to select these points. So our first point will be again the origin, 0 and 0, and you will notice that the coordinates of the point that we choose appear here, and that's also very useful. Then we can click at this grid point. The second point will be 3 and 0, and the last point will be 6 and 0. With right click we can exit out of this command. Now that our member is created, next we will insert the supports, and again we go up here in the toolbar, choose for that nodal support. Then in this dialog we can set our support conditions, and the first support will be a hinge one. We click OK, then we can graphically choose the point for that support, and you can see now the support is created. We do exactly the same for the other two nodes, but those will be able to slide along the x-axis, so we choose sliding in x. The next thing that I want to show you is not really necessary for our example, but it makes the calculation sometimes easier, especially if you have more complex structures. Right now, as you can see, we have a system out of two members, the first one here on the left side and the second member on the right side. And we can merge these two members to a set of members. For that, we will select these two members. We can do that with the control key and left click. And then with right click, we can find create set of members. Here we choose as type continuous members. Since we have them already selected graphically, we can see here that these two members are set automatically in the section. And with OK, we can close this dialog. Now we can see here's a frame around our members, which shows us that these members are now a set of members. What's missing now, of course, are member loads, and for that we can find up here in the toolbar this button called New Member Load. And if we click here, the window for load cases appears at first, since we have to define before creating loads a load case. Here we will choose all loads and turn off the self-wait. Next, we can define our load. Here we change reference to from members to sets of members. As type, we can choose force. As direction, we can keep that in the Z direction. Our load parameter down here will be 5 kilonewtons per meter. And then again, we can assign the load graphically to our members. Now that our system is complete, we can go up here and calculate this one. And then we can see our results. We change to the wireframe model, and then our results like deformation, internal forces can be displayed. So this was our third part of modeling in RFEM 5, and in the next upcoming videos we will learn how to model different type of structures. Again, thank you for watching, and if you have any questions you can write in the comments below, or you can also visit our website, search anything that you need at dlubal.com.